Hey Pat, so we're back here now. We spoke about inputs. Now let's, I suppose, look at the outputs. We're producing a gas. Just talk us about the gas that we produce first. What is it?
So the gas we produce is biogas. So the gas we're producing here is between 51 and 52, 53% of a methane content in the gas. The balance is made up of CO2, carbon dioxide, and some contaminants in the gas, which is removed in a scrubbing system using.
Okay, what have we got here in front of us, Pat?
So what we have here, basically, the liquid fraction is taken from the post digester. It's taken over here and it goes through a slurry separator. The idea of this unit here is it takes the solid fraction out of the liquid and it puts the liquid into this tank here and it leaves the solid fraction here on the ground.
Okay, so tell me about this solid fraction. What's the uses of this, Pat?
So this solid fraction is very high in the P and K from the process is stored in the solid fraction. So it has huge usages in terms of number one, I suppose, increasing the P and K value organically in ground, and also increasing the organic matter in ground, which a lot of agricultural ground currently is suffering from overusage. The liquid fraction here is where the nitrogen element is stored, and obviously that's put back out on the ground after the silage is cut every time as your nitrogen input, and it offsets the chemical nitrogen usage on the farm, and would in going forward, I suppose, in other plants, the idea was that it would offset a lot of the chemical nitrogen requirements.
Okay, so I suppose farmers traditionally may have used slurry. Tell me, is this product here that you're producing a lot better?
Yeah, well, I suppose the big thing it is the nitrogen availability to the plant is probably 30 to 40% higher. Also, I suppose, the fact that it's gone through the digestion process, the pathogens in it, the reduction is, you're probably up on 90-95% of the pathogen reduction. So basically you have a we call it a cleaner or a more efficient supplement for a nitrogen supplement for the crops that's growing, whether that be grass or whatever else.
And there's new technologies now, Pat, coming in relation to putting more nitrogen back in, isn't there?
Yes. Well, other plants that we've installed a nitrogen or a nutrient recovery system, which is basically using vacuum distillation to separate the ammonia from the liquid fraction. That ammonia is really concentrated, so you can take that off-site and sell it to companies, I suppose, or operators that will be needing a more concentrated form of ammonia. And I suppose what that does, I suppose, when you look at the water quality reports from Ireland over the last number of years, they're deteriorating, and the main reason, I suppose, is a lot of the chemical nitrogen that's used, and that could offset a lot of this chemical nitrogen. If you look at the mass balance of the whole system, we should be nitrogen neutral, so to speak, with the amount of nitrogen that we have available through cattle slurries and organic material versus bringing chemical nitrogen into the country.
Okay, so we've produced some outputs here. So we've got our, this is our bio-digestate. We've got our liquid, I suppose, fertilizer source. And then just talk through about the biomethane. So what happens then?
So the biogas that leaves the plant, I suppose, is brought over here in underground pipes. Gas condition skid, which is basically it cools the gas to remove any moisture, it reheats the gas, and it puts it through a carbon bed to take any of the contaminants out of the gas, which is on an agriculture based plant is very, very little. You have a small amount of H2S and a few other contaminants.
Okay.
From there the gas goes into an engine inside. We won't be able to talk in there, but you can hear.
Yeah, I'm hearing a lot of noise. So I guess that's the engine inside there.
Yeah.
So the gas is converted, I suppose, into driving an engine to make electricity. Is that the principle?
Yes, the biogas, basically, it's the same as a natural gas engine. Your energy value is about half of what natural gas is, obviously, if you're 50-55% of a CH4 value. So it's basically a derated natural gas engine.
Okay. This is your plant room in here, is it?
This is the control room.
Control room.
You can see the functions of everything here. Our digester, our primary digester here, where the feed sequence goes in, and our different motors, our different pumps operates. The secondary, the post digester, we can see our two mixers here and the amps that they're taking. We keep it, the temperature of this is at 49.9 degrees. The height of the digested unit is recorded, and we keep the mixers going based on the amount of amps, so based on how dry or how wet liquefied the material is.
Lovely. Thanks very much, Pat.